In this video, we're going to talk about formal charges. Now, formal charges are simply just the charges that you find on each element inside of your structure. So hopefully this video will give you a little clarity on how to find a formal charge. So first of all, what is a formal charge? Well, a formal charge is a hypothetical charge an atom has in a molecule or a polyatomic ion if the bonding electrons are shared equally and lone pairs belong solely to a single atom. Now, these are considered hypothetical because formal charges are only for quote-unquote bookkeeping purposes. And we just use it to determine the most plausible structure that is going to be relevant for what we're working with. We do have some rules to follow, so let's just talk about our rules real quick. The first one, if a molecule or a compound is neutral, the sum of the formal charges has to equal 0. For polyatomic ions, the sum of the formal charge has to equal the charge that you see for the polyatomic ion. Now, a Lewis structure where all the formal charges are equal to 0 is favorable to one with formal charges. So if you have a couple of different structures and you're working with resonance structures, and you have one that all the charges are equal to 0 and one that has a charge that might be a formal charge that's not 0, the all 0 one is going to be more favorable. Number 4, a Lewis structure with a large formal charge, which is a positive or -2, positive -3, is less favorable than one with a lower formal charge, whether it's 0 or positive or -1. Now, given two Lewis structures with similar formal charge distributions, the most favorable structure has a negative formal charge on the most electronegative atom. Now, we do have an electronegativity chart that is available to you on your D2L. If you don't see it in D2L, ask your instructor. They can make it available for you. So the first thing that we want to do is talk about formula. The formula that I like to use is a formal charge equals a group number, which comes from your periodic table. It's also known as your number of valence electrons, okay? Then we're going to subtract that from the number of bonds, and we find that this is how many bonds the element shares, the number of dashes that you see in the Lewis structure. And we're going to add those together with the number of unshared electrons. And basically we're looking at how many unbonded electrons this element has, or just the number of dots. So basically we're going to take that group number and subtract it from the sum of number of bonds and the number of unshared electrons. So let's do an example and throw it out there real quick. We're going to work with HCl. If we're working with HCl, we're going to go ahead and the first thing we're going to do is draw our Lewis structure. Now, if you're not sure how I came up with how many electrons is needed for this Lewis structure, you might want to check out the actual video on Lewis structures. But that's where we're at. What we're going to do is we're going to take our formal charge, which is our group number, right? And what we're looking at with HCl is we're going to look at for H, we have to do them for each individual, right? So for H, our group number is 1, our hydrogen is in 1. We have one bond, it's bonding with that Cl or that chlorine one time. And then the number of unshared electrons where there are none. So that gives us a grand total of 0 charge. Same thing for the chlorine, we do the exact same thing. That chlorine is group number 7, or it has 7 valence electrons. It's the bonded one time to that hydrogen, and then the number of unshared electrons is 6, and do that math and we come up with a formal charge of 0. And so you're looking at H0 Cl0. So let's look at another example. Example number 2, we have CF4. I went ahead and drew the Lewis structure out for you guys because if you are struggling with Lewis structure, go into your video library and find that Lewis structure video, and that'll get you where you need to be, hopefully. So if we have a CF4, let's just talk about our CF4. We're going to do it for each individual atom. We're going to figure our formal charge for each individual element. Okay, and so for the carbon, I'm looking, this is what I did. I pulled that group number, how many times is bonded to that fluorine, and then the number of unshared electrons. I do that for my fluorine also. So group number 7 is bonded to to that carbon one time, and it has no valence electrons. Now, if that fluorine was two different elements, you would have another line down here with your other element underneath it. But because those fluorines are all the same, they are all from group number 7, they are all have one bond, and they all have 6 unshared electrons. So our formal charge is actually going to be hydrogen 0 and fluorine 0. So let's just throw another example up here real quick. So we have example number 3. It's a ClO3. And so we have to follow the octet rule. There is a video in your video library about the octet rule. So if you're confused about that, go check out that octet rule video. Now I went ahead and threw everything on the slide for you. I drew the Lewis structure. It has brackets and a charge because ClO3 is a polyatomic ion. Now, if you're confused about polyatomic ions, go over to the supplement area in your D2L and grab a hold of the common polyatomic ion sheet. That'll get you where you need to be. So what I've done is I went ahead and I did all the formal charges. And the reason I did this is because I just wanted to show you from the last one, all those oxygens are the same. So I don't need to do all of the math and all of the grunt work for all of the oxygens, okay? I only really need to do it once, but I went ahead and threw it out there for you so you could just see that's what I was talking about a few minutes ago. Now, ClO3, what we're looking at, the first one that you saw on the previous slide, this one right here, this is actually following an octet rule, okay? However, carbon's not happy, so we have to make carbon happy with that octet. So we're going to go back over here to example 3. So that ClO3 has resonance structures, and I know that because it has a multiple bond. But what I'm looking at here, I just wanted to show you, is this is going to be labeled structure number 1, okay? This one will be structure number 2, and then, of course, our last one on the right is going to be structure number 3. And I'm breaking those down for you because we're about to just break this whole thing down into several slides, and I want you to keep aware of what's happening. In structure 1, your double bond is on your right oxygen and your lower oxygen. Structure 2, your double bonds are on either side with your oxygen. And then in structure 3, your oxygen and your lower oxygen, your oxygen on your left and your lower oxygen hold the double bond. So let's get right into it with this first one. We have example number 3, which is our structure number 1. And so what I did, because we have multiple bonds, I know that my oxygens are going to probably be different. 2 of them are going to be the same because they're the same, but one of them is going to be different. So I went ahead and worked all my formal charges, and you guys have seen how that works and what the chart with the actual formula is for that. So I just kind of threw it up here for you so you could see. But I wanted you to see on the left is my oxygen number 1. This one right here, oxygen number 1, and it lines up with this one right here. 2 lines up here. 3 lines up here. Maybe that'll give you a little heads up when you're trying to figure out how I'm lining these up and how the formal charges change. So let's look at the next slide. We go to the next slide, and it's basically the same thing, but we're looking at structure number 2. I still have all of my oxygens labeled the same, but if you look, my charges are now different. I did the exact same thing, put all the information into my formula, and my numbers are different. Same for structure 3. Still labeled the same, but of course they changed a little bit. So I'm just showing you how these resonance structures change and how to use the formal charge to figure out which one is going to be the most plausible structure. So this is what we have going on. We have our structures here, structure 1, 2, and 3. And in red, I've gone in and written the charges on each one. Okay, so if you're looking at these, all the CLs have a 1, a +1, but my oxygens change a little bit, but they don't change much. That just -1 is bouncing around from one to the other. Wherever that single bond is, you see that -1. So I just kind of want to make you aware of what we're actually looking at. If you guys have any questions about this particular subject, about formal charges, be sure to reach out to your instructor. I hope this video has given you a little bit of insight on how to figure out your formal charges and using your formula.